in calculating the area between curves, if you have function y equals to f of x, and you calculate the area below the function bounded to x-axis between a to b, it's basically the definite integral of the function. If you have another function like g of x, and you have the area of g of x bounded between its curve and positive part of x-axis between a and b, it's another definite integral. But the question is, how do you find the area in between these two graphs? So the larger graph, the smaller graph, larger area, smaller area. So it makes sense to calculate the larger area and subtract the smaller area from the larger one. That's basically the idea of finding the area between two curves. The area between two curves is the definite integral of larger function that has larger y value minus the definite integral of the y value which is smaller, which in this case is g of x. So basically you calculate the definite integral of f minus the definite integral of g. Sometimes we have to switch around and calculate the integral with respect to y and look at the larger x value. So in this question, find the area of the region in the first quadrant that is bounded above by square root function and below by x-axis and the line, increasing line y equals to x minus 2. You can take a look at the visualization here. So if we graph these using Desmos, this is what we have. First of all, you have square root. The square root function is on positive part of x-axis along with the origin. And this increasing line is this line here. But please note that the question says you are in the first quadrant. It means that we are skipping this part of the area. We just look at this area in between positive part of x-axis. We are not considering the negative part of y-axis, just looking at this portion. But calculating this integral is basically entail calculating the area of the portion bounded between square root of x and y equal to 0, along with the second portion, which is square root of x, and down here, the smaller y value is x minus 2. So we're going to calculate each one of these separately, then add the area and to find the total area eventually. To find this little piece, the x value, you just need to set this function equal to 0 and x becomes 2. But the intersecting point between square root of x and this line needs a little bit of algebra. First of all, make sure to set f of x and g of x equal to each other to calculate your x value. Square root of x is equal to x minus 2. Raise both sides to the second power. On the left-hand side, you get the x. On the right-hand side, you get x minus 2 to the second. Now, x is equal to, if you write x minus 2 to the second power in expanded form, x squared minus 4x plus 4. Bring all terms to one side. So we get x squared minus 5x plus 4 equal to 0. By factoring, you have x minus 1 times x minus 4 equal to 0. So x is 1, x is 4. So this says that, hey, when x is equal to 4, you're intersecting these two graphs. When x is equal to 4, your y value is equal to 2. Now let us set up the integrals. The integral on the left-hand side gives you the definite integral 0 to 2 of square root of x. On top, it's bounded by square root function, and down below, it's bounded by y equals to 0. So when x is bounded between 0 and 2, the larger y value minus the smaller y value is square root of x minus 0. So again, square root of x is on top here, and 0 is down here, which is equal to square root of x. The definite integral of 0 between 0 and 2 of square root of x dx can be calculated using the power rule. It's going to be 2/3 x to the power 3/2. X is bounded between 0 and 2, which is 2/3 2 to the power 3/2. Now let us move on and calculate the rest of the definite integral. For x bounded between 2 and 4, f of x minus g of x is square root of x minus x minus 2. If you distribute negative sign, you get the square root of x minus x plus 2. Now the definite integral between 2 to 4 of square root of x minus x plus 2 dx is, you have 2/3 x to the power 3/2 minus a half x squared plus 2x. X ranges between 2 to 4, which is you plug in 4 minus you plug in 2. And when you combine these two quantities together, the total area becomes 10 divided by 3. So you either separate these two integrals and do the calculations separately, or you can just list them next to each other. If you list these next to each other, this quantity and this quantity, they are opposite of each other, they get canceled out. So you're left with 2/3 4 to the power 3/2, and then these two get canceled out as well. You get 4 minus 2, which is 2. So basically, you're just having 2 plus 2/3 and 4 to the power 3/2. 2 squared, exponents get canceled out, so you get 16 divided by 3 plus 2, minus 2, and then, as you can see, the outcome is equal to 10 divided by 3. So these two quantities, they get canceled out, and you have a negative 2, and these two also, they get canceled out, and this quantity is basically 16 divided by 3, and 16 divided by 3 minus 2 is equal to 10 divided by 3.